Hello friends, in today's video we will discuss about the conditions and modes of preservation of fossil. So in this video we will discuss about what are the conditions that favors the fossilization process and what are the modes or what are the in which form we are getting the fossil. This is the modes. What is the modes we are of preservation. So in this video, as you can see the image, one dinosaur in the geologic past was roaming around over the surface, and after its death, it got buried into the sediment layer, and the thickness was very much higher. But after it, some tectonic movement happens, and due to upliftment, it comes near to the surface, and then during because of the erosion it got exposed to the surface, and the paleontologist and geologist get it as fossils. So this is how we are getting the fossils. But as I discussed this fossilization process, but it is actually in the geologic like in natural condition, it is not that much easier to um, get fossil the dead organism fossilized. So what are the conditions? We will get more deeper into the conditions of preservation. So the first condition is presence of hard skeletal material. So there should be some hard part of the organism that could be preserved as fossil. So what are the hard parts? As we know, as we are human beings, we have bones inside our body. So this is our endoskeletons. So like this, there are some other organisms that mainly invertebrates. What are those? Like gastropods and bivalves. They have their exoskeletons. In that exoskeletons, they have their upper body, which is covered with a calcitic material which is very hard in nature. So it safeguards them from that external attackers. So these are we can say, but these are hard materials. So what it is written here, the soft organic tissues are usually found decomposed and destroyed after the death of the organism by the activity of bacteria in the presence of oxygen in the atmosphere, and are unlikely to be preserved. So the soft parts will get decomposed by the bacteria with the presence of oxygen. So it is, we cannot found soft parts, although we can found, but it is very rare condition. There are some conditions where we can get the soft parts. So what are these conditions? We will discuss it later. So hard tissues or skeletal materials may escape such destructive process for a considerable time, and may favor its fossilization provided subsequently other latter conditions to be fulfilled. So the hard parts we can get as fossil. It can favor for prolonged time. We can get the hard parts, and suppose some other conditions should be there, like suppose the environment will be acidic, even the hard parts will also get destroyed. So some other condition will be there mostly, but mostly we can get the hard parts only. We can see the that schematic diagram or sketches. You can see there is a in the left side you can see a ohm. As we know, the soft bodied ohm like annelids, we cannot get any fossil of these ohms because they don't have any hard parts. But after death we can get the fossil of bivalves, and even fish. We can get the fossil of fishes that draw back our attention to Ordovician. So how it happens? Because they have hard parts. After the death, their soft parts get destroyed, but their hard parts get fossilized and preserved for so many periods, so many times. So we can get it as fossils. their even their impressions or after replacement also, their suppose the calcitic part got replaced with what like iron oxide or some silica, but we can get that but that impression will be there. That is that although this the fossilization, this is not like we cannot say it after replacement we cannot say the fossil as a very good preserved fossil, only well preserved one, but this is we are getting this fossil because although we cannot get soft parts, but the hard parts are still there, although their impression is there, but it is still there. So this is first, this is the one first condition. Then second condition is detachment from atmosphere. So what is say oxygen is a decomposing agent. So after the death of an organism, the dead body needs to be detached from the atmospheric contact by some natural process as early as possible. Otherwise it will be easily decomposed by bacteria in presence of oxygen. Short parts will go fast, followed by the hard parts. Marine and other aquatic animals have already some plus points over terrestrial animals. So, as I told before, oxygen is a very well-known decomposing agent. So, the organism after their death should be buried or should be detached from the atmosphere in a way it possible, but it should be detached from the atmosphere. So, so that it will be preserved for some prolonged time. So how marine and aquatic animals have a plus point? Because after their death they will lie on the surface of the marine beds or river beds, but it is still not have any contact with the atmosphere, because the water body will be above the organism. So there is still they have good chances of preservation. In some cases, suppose one landslide is happening, so in that case the organism is dying in that landslide, also buried in that landslide, so it can be preserved. There is no chances to get after the death. There is no chance to come contact with the atmosphere. So it will be there will be a very good chance for preservation. You can see the schematic diagram here. After the death in this the fish, after the death of the fish, it is lying on the muddy lake bed, and it is got covered with sand and silt, and we can get it as a well preserved aquatic fossil. But in case of terrestrial organism, after his death, the scavengers bacteria are decomposing it, and with the presence of oxygen, and even the hard parts also get scattered with some natural agency, also with some other um, organisms. So we are getting some bones, teeth, very scattered parts we are getting. This is not a good preserved fossil. Okay, then we'll go to third condition. What is the third condition? Sedimentation and permanent covering. So so it should be detached, but the covering or the detachment should be permanent. So what it is written, a dead organism is more likely to be preserved when it is quickly and permanently covered by sediments. Fine grained sediments such as clay, silt, and chemically precipitated limestone are specifically good for preservation. In rare cases, sudden rapid burial during catastrophic events can produce exceptionally fossil-rich rocks called coquina. So, after the death of the organism, it should be preserved very so much quickly, and the cover should be permanent. Suppose one organism buried with ice, suppose winter is there in a hilly terrain, and suppose snow covering is there, and one organism got buried within the ice cover, and but when the season changes, the ice got melted, and it exposed to the surface. This is not permanent covering, and it will be decomposed by some agents like bacteria and all. So it should be permanent. And fine grained sediments, such as clay and silt are very optimal, because these sediments will not allow the atmosphere or water to percolate within the sediment, and it will make a very permanent covering, and it will also preserve the fossil as a very intact. It will preserve the rock fossil intactly. Like so, in rare cases, sudden rapid burial during catastrophic events. Suppose one landslide is happening, and a bunch of suppose aquatic animals are roaming here and there, but one sudden landslide is happening, so the aquatic animals are getting buried inside the inside the sediment covering. So the rock we can get from this buried aquatic organism. It The rock should contain a high amount of skeletal materials. So this is known as coquina. Then chemical environment. What are the chemical environment? Chemical environment, it is depends of there are two type of environment, like acidic environment and alkaline environment. As we know, the pH is suppose less than 7.8, it is acidic environment, where these calcareous skeletons got dissolved easily. But in case of alkaline environment, when pH is 7 higher than 7.8, greater than 7.8, it is the siliceous skeletons will be get preserved. But then there will be no what calcareous, sorry, siliceous in alkaline environments. The siliceous skeletons will be dissolved, but the calcareous skeletons will be preserved. So don't get confused here, because this is very simple. In what happens, there is a zone known as calcium carbonate compensation depth zone. CCCD. Below CCCD, the below CCD, the calcium carbonate cells we can get in marine. Suppose what we are means we are discussing about marine environment. In marine environment, microfossils are very important. Microfossils, some are calcareous and some are siliceous. What are calcareous? Suppose foraminifera, ostracods, these are calcareous, but and the radiolaria, diatoms, these are siliceous. So below CCCD, only the siliceous diatom and radiolaria skeletons will be get preserved, and above CCCD on the foraminifera, both planktic as well as benthic and ostracods get preserved, because above CCCD, the environment is alkaline. There we can there this calcareous cells will be get preserved, but the siliceous cannot be there. But in siliceous will be there, but mostly calcareous skeletons will be there. But below CCCD, so only siliceous skeletons will be there. No calcareous skeleton will be there, because below CCCD it get dissolved. I will explain this by a simple reaction. So this is I am taking one. Sorry. Just 1 minute. I'm taking. Okay. This is a very simple reaction. You can see. In fatigue zone, what happens in fatigue zone? Actually, in fatigue zone, the CO2 in fatigue zones, the CO2 get absorbed by the the um, plant materials. In fatigue zone, so many plant materials will be there. So in fatigue zone, the carbon dioxide will get absorbed by these these plant materials. So this is a very simple reaction. Carbon dioxide reacts with water, giving rise to carbonic acid, and this carbonic acid dissociates into H plus ion and bicarbonate ion. Then even biocarbonate ion also get dissociates into H plus ion and carbonate ion CO3 plus 2 CO3 2 minus. So what happens here, when in the fatigue zone CO2 is get absorbed, so the reaction will be less. So if the reaction will be less, though H plus ion will H plus ion will be less. So if H plus ion will be less, the environment will be what, alkaline, because H plus ion more, if H plus ion will be more, the environment will be more acidic, and if H plus ion will be less, the environment will be more alkaline. So below CCCD, carbonate compensation depth, the there will be no but for like plant material, this, as this is not photic zone, no plant will be there, so carbon dioxide will not be absorbed by the plant, so more carbon dioxide will be there, and it will react with H2 and giving rise to more H plus ion. More H plus ion means if the water is acidic. It is also related with the temperature also. The temperature will be less, the water will be more acidic, and as we know, in acidic water the calcium carbonate will not it will the calcium carbonate will not preserve, it will react, it will dissociate into calcium ion and CO3 ion. So this is the process, this is very important. Then effect of diagenesis. Diagenetic process may operate in sediment to convert into a suitable hard rock. Leaching by acidic groundwater may remove calcareous skeletons. Inorganic minerals in solution within groundwater may replace the organic skeletal matters partially or completely. Silica in solution frequently replaces CaCO3 of calcareous skeleton, and recrystallization often results hardening of organic cell. So as we know, diagenesis is a process where in this process the soft sediments get into hard sedimentary rocks. So in this process there are several steps, like it get first it will get compaction, lithification, the water will be removal of the water, several process will be there. In this process, for the sediment that contains fossil, the fossil also get affected by this process. How it so first it what it is saying, leaching by acidic groundwater. So when acidic groundwater will run through the sediment, it will leach the calcareous skeleton. And another it is showing, it is saying inorganic minerals in solution in groundwater may replace. So the so in many times calcite is replaced by the silica or carbon, sorry, in silica or iron oxide that carried by the this water. So this is what it is saying. So recrystallization often result hardening of the cell. As you can see in the image, the the reddish one is replaced by the carbon, sorry, the iron oxide. But the you can see the both are the ostracode. One is from Jurassic and one is from recent. As you can see, the recent one is very smooth surface, and the shining kind of thing, shining kind. This right, this left one is so in red, cherry red in color, which is made up of iron, replaced by iron oxide. And this is the process of diagenetic process, as I have told. And similarly, less deformation of and metamorphism or rocks. As you know, the deformation and metamorphism and its related igneous intrusion may destroy the fossil. So here one, so if the rock will is under if the rock have undergone very less metamorphism or no metamorphism, the fossil within the rock will be preserved very nicely. But if the reverse condition, it is like the fossilized, the metamorphism is very high with high deformation, there will be very less chance of getting well preserved fossil. In this image you can see there is a trilobite fossil which get which got deformed by metamorphic process like that. Then we'll go to mode of preservation of fossil. What is the mode of preservation? As I have told, soft part is very rarely preserved. I have already told. So soft part as fossils. So in which condition we are getting soft parts? Embodiment of insect in fossil resins or umbers. Suppose one insect is got trapped in umber. Umber means resins we are getting where that comes out from a tree. So this organism, this insect got sealed inside the umber. So the hard parts as well as the soft parts get preserved. And another is frozen mammoth, woolly mammoth, and rhinoceros within Pleistocene Siberian ice. In Siberian ice, paleontologists get some mammoth. The mammoths in which they got the short parts like flesh and skin also got preserved. So these are some rare condition we get the soft parts. Rare or special condition also. Then hard parts we can get, but we can get the hard parts in two forms, one altered forms and one unaltered forms. In unaltered forms, how it we get original structure will be there and composition will be there. So it is the hard parts will be preserved as unaltered. So hard parts are composed of organic matters which may be calcitic or aragonite, and such as exoskeleton of corals and brachiopod, mollusks and echinoderms, and phosphatic like vertebrate bones and conodons, and siliceous such as exoskeletons, radiolaria, sponges, and some algae, and like diatoms, and organic hard parts are composed of chitin found in many arthropods, keratin, cellulose, and bark. So these are some hard parts. If we are getting the same composition as well as same structure, we can say as unaltered hard parts. But we can most of the times, if the rock is if the fossil is very older, suppose Jurassic, Triassic, like we are getting some fossil from Ordovician. In that case, the hard parts will be there, but it get altered by some other fossils. How they, but the alteration is proceeded by several other methods, such as distilled fossils. What is distilled fossils? Some original material is lost by leaching, making the fossil porous and lighter. Suppose one bone is there and some part of the bone has been leached out by groundwater something. So this is known as it making it porous or lighter. This is known as distilled fossils. Then permineralized fossil, when the materials fill the pores of the skeleton. Suppose silica, the the suppose the bone, the porous part of the bone is infilled by silica or some iron oxide or some other material, and this is known as permineralized fossil. In petrified fossil, the original material is replaced by new minerals while structure remain mostly intact. In petrified fossil, what happens, the structure will be there, but the original material will not be there and it is replaced by some other material. Silica is the common replacing material, and other replacing materials include hematite, pyrite, and calcite. This is important. Then carbonation. In carbonation, what happens, it removes the organic material and leaves mainly carbon. So plant fossils often appear black. So as we know, in coal beds where most we get the plant fossils. So the plant fossils, it will get disappear, it will be disappeared, but one thin film of carbon will be there. It appears black. This is known as carbonation. So coal formation is an extreme form of carbonation. Then recrystallized fossil form, when unsuitable minerals change into more stable ones under pressure and temperature. Recrystallized fossil. So commonly aragonite commonly recrystallized to calcite, as aragonite is less stable and calcite is more stable. Isochemical alteration. What is isochemical alteration? When crystal size and form with the crystals, it changes crystal size or form without changing composition. So aragonite crystallized to calcite is a form, is a kind of isochemical alteration. So another statement is written here: aragonite is mostly recrystallized into calcite as the latter is more stable form. Arachnotic skeletons are very rare within fossils older than Cenozoic. So before Cenozoic, the fossils we are getting mostly calcite. As although it was earlier it was aragonite, but it get replaced by the calcite by isochemical alteration. This is a picture of image of petrified wood in the left, and carbonization. The carbon films are there. So this is process of carbonization, and indirect fossils are also a form of mode in a mode that we get fossils in the form of indirect fossil. What are indirect fossil? We get some mold fossil. Mold fossil. What are mold fossil? Mold fossil forms when the original cell or skeleton is completely dissolved or removed, leaving a cavity. Means, जो means what? Suppose one during the making of some sculpture, there will be some cavity kind of material will be there. They will fill the mud into that cavity, and the sculpture will be ready. Like this, the mold will be the cavity of the fossil. If the surrounding sediment is fine grained and external shape of the hard and external shape and surface details of the cell may be preserved as an external mold. So external one is external mold and another is internal mold. There are two kind of molds. If external surface is preserved as mold is external mold, and if internal part is preserved is internal mold, then I will explain it with some images. And generally infilling, if some infilling will be there, it will be known as cast fossil. Other indirect fossils are trace fossil, coprolites and gastrolites. What I have told before, trace fossils are the remains of their activities, like the crawling, sitting, and borrowing. These are this kind of activity. Their if their remains are preserved as fossil, they are known as trace fossil. Coprolites are thus fecal remains, like like cow dung, like that. Their excreta material is known as coprolite. And gastrolith in stomach stones, we are getting some stones in previous lecturer. I have told about the all these kind of things. So you can see mold and cast. So this is a mold. The uh, shape has been preserved here, and this is the cast, this is the infilling, and this is the external mold. External mold means you can see the external part of the gastropod has been preserved. And internal mode means suppose infilling was internally, it was infilled with some clay kind of material, and it got hardened. So the internal part has been the remains of internal impression of internal parts will be there. So this is known as internal mold. Okay, this is the end of the video. Thank you.